let's see to have so much fun. Yes, come join us. Did you guys know that the seesaw is in the concept of equilibrium of the rigid body? What? Really? Before that, let's get to know about the topic.
The seesaw, the figure below show a classic example of a rigid body in equilibrium. As you guys can see, a beam of length L is placed on a pivot, and for the beam to be in equilibrium, two forces F1 and F2 act on each end. The force acting on the beam is the normal force, meanwhile, the weight force must be at the center of the beam. Don't forget about the notes. In a rigid body like a seesaw in equilibrium, the sum of torques acting on it is zero. Torque is the tendency of a force to rotate an object upon an axis. In equilibrium, the clockwise torques are balanced by counterclockwise torques. For a seesaw, this means that the product of the force applied on one side and its distance from the pivot, which is fulcrum, is equal to the product of the force on the other side and its distance from the pivot. Mathematically, this is expressed as sum of moment anticlockwise equals to sum of moment clockwise. This equilibrium condition ensures that the seesaw remains stationary and doesn't rotate. Two kids balancing a seesaw satisfy both conditions for equilibrium. In the image, we see the lighter child, which is the boy, sitting farther away from the pivot to create a torque equal in magnitude to that of the heavier. Yay! You guys know about the seesaw, but I'm wondering how a seesaw works.
Next, I will be explaining how seesaw works. Seesaw is a type of lever with a central pivot point known as the fulcrum. It is typically placed in the middle, allowing the seesaw to rotate around this point. In the context of seesaw, torque is generated when individuals apply a force, which is their weight, at a distance from the fulcrum. It can be written in an equation: torque equals to force multiplied by the lever arm, which is the distance from the fulcrum. For the seesaw to be in equilibrium, which is not rotating, the torques on either side of the fulcrum must be equal. This means the person that is heavier makes distance from the fulcrum on one side and will be balanced by the person on the other side. And now, we already know how seesaw works.
Oh, how about the swing? Does the swing also related to the equilibrium of the rigid body? Yes, it is. Let me explain to you.
Now, we will talk about swing related to equilibrium rigid body. When the swing at rest, we call it as static equilibrium. Static equilibrium of a rigid body is the state where a solid object isn't moving because it influences air balance. When the swing is moving, we call it as dynamic equilibrium. The body is moving with a constant velocity. So if the net force acting on the body is zero and it is still moving with some constant velocity, the body is said to be in dynamic equilibrium. When you sit on a swing in the equilibrium position, there are two forces acting, which is the tension in the chain and the weight of the rider. When you swing your legs forward and throw your head back to get the swing to go, you are creating a torque on your body. At the points where the potential energy is at its maximum, the angular momentum is zero. Then at the bottom of the arc, as you go forward, the kinetic energy is at its highest and the potential is at zero. You will have a positive angular momentum. This process reverses as you go backward, so your angular momentum is now negative. In this process, the angular momentum is conserved because your legs and head are applying a torque to you.
This reminds me of the Quran verse in Surah Ashura.
In the Quran, the earth is often presented as a symbol of stability and balance. For an example, in Surah Ashura, ayat 17, أعوذ بالله من الشيطان الرجيم الله الذي أنزل الكتاب بالحق والميزان وما يدريك لعل الساعة قريب. The meaning is, it is Allah who has sent down the book in truth and also the balance, and what will make you perceive, perhaps the hour is near. While the specific concept of torque is not explicitly mentioned in the Quran does emphasize the importance of balance and order in the natural world, which can be related to the concept of torque. These verses emphasize the balance and stability of the natural world and the earth in particular, which can be related to the concept of torque.
5, 6, 7,